Awesome. Well, yeah. So on that note, I just wanted to very quickly, before we begin, quick flavor of the room, quick temperature. How many people have heard of Lisp flavored Erlang? Anybody? A couple people? Yeah. How many people have heard of Lisp? Yeah, more people. Heard of Erlang? I'm assuming probably a lot of people. And I'm assuming it's the Elixir meetup. We've all heard of Elixir, so we don't need to go talk about that. But what is Lisp for the people who maybe haven't heard of it? Here's some definitions that you might have heard in the past. It's a language. Lisp is a language. Well, yes, it is, but also, no, it kind of really isn't. We'll see why in a minute. So maybe Lisp is a family of languages. Well, I mean, again, yeah, kind of, but also kind of no, because you would think a family would be related, and a lot of these languages really aren't, and we'll see why. So maybe Lisp is a syntax. Yeah, okay. So that's a little bit more like it. So what is the syntax of Lisp? We said Lisp is a syntax. So you can think of this as a quick field guide to identify if the language that you're looking at is a Lisp or not, right? So this isn't the entire syntax of a Lisp, but if it has these things, you can think that it's a Lisp. So atomic symbols, right? You can think of this as any sequence of characters that starts with a letter. Punctuation. This is the characters, the period, the open, and the close parentheses. Ooh, parentheses, finally. Cons pair. So this is made up of the previous two things we just saw. So it's the punctuation and the symbols put together. X and Y are symbols, and we have our punctuation, right? Heard that one before, huh? Lists. Lists are made of cons pairs. So this is the equivalent thing, right? Again, looks kind of familiar maybe for some of us Elixir people. And the last thing, programs and data are written in the same syntax. That doesn't sound very familiar. But we'll talk about that in a bit. This is a standard disclaimer here. For right now, this is all you really need to know about the syntax of Lisp, right? So, okay, so we know the syntax. So how can we maybe represent some data structures using this very, very basic syntax that we've learned so far, right? So lists, we've already seen lists. That's pretty easy. We can also do keywords, right? That's a keyword. You know, we've seen this before. We have keys and we have values. We can do maps. This is maybe just another way of writing the same thing, but it's, you know, a different form. We can also have some other data structures, right? What about a tree? This is a tree that might be familiar to a lot of us Elixir developers. This is HTML, right? HTML is a tree structure, but there's some other things that we can represent in a tree structure too, right? Like a program, for instance. Programs could be written in a tree structure. So let's just chew on that one maybe for a little bit and switch gears a little bit. And let's talk about the history, right? So why does some of this matter? Where does some of this stuff come from? Where do these ideas come from, right? And, you know, I'm not a historian. This isn't a documentary. This is more of a story than it is a history, right? So what does that mean? I mean, to be generous, that means that I'm stretching the truth a little bit. And to be mean, that means I'm lying. So don't quote me. So there's many possible infinite tangents that I could go on here. So I'm just streamlining things for you, right? And every story needs a protagonist, right? So this is our protagonist for this story. This is John McCarthy, right? And our story starts in the before times, right? So he was working with a computer called the IBM 704, right? This is a very, very weak computer by today's standards. I asked ChatGPT for a comparison and it laughed at me. But we're going to try and do one anyway. So it could do about 40,000 operations per second. Modern laptop is going to do somewhere north of 3.2 billion. So just a quick comparison, right? Like this is not a very fast computer, right? This is also the era of batch processing, right? So what does that mean? That means that all of your programs are written on punch cards, punched little holes on these punch cards, and then you handed a big fat stack of these cards to somebody who is an operator who would take that stack, would put it into the machine, would get a printout of your code and hand the printout of your output back to you, right? So very, very inefficient. You know, this is not a very fast way of writing programs. Okay, so what are some things, why do we care about John McCarthy? Why are we talking about him in Elixir Meetup? So here's some things that John McCarthy worked on that are relevant for us, right? So language made up of expressions, seen that one before. Atoms are different than strings. That's an interesting one. We've seen that one before. First class functions, recursion, garbage collection, compile time programming, Interactive programming environment. REPL, who's heard of that, right? Read, eval, print, loop. That is standard Lisp stuff, right? So this is going back to the very, very beginning. More than one program running on a computer at a time. Back in the day, they called this time sharing, and this was a very big, brand new idea. Remember what I was talking about, punch cards and batch processing? Having more than one person being able to use the computer at one time was huge. Nowadays, we just call that how computers work, right? We got the internet, we got operating systems. This is so banal of an idea that we don't even have a name for it anymore. This is just how it works. AI, he also was the person who coined the term AI, right? And you might notice that all of these things have something in common, right? Why are we talking about it at Elixir Meetup? Because we can do all of this stuff in Elixir, right? So this is the very foundations of some of the stuff that we are now experiencing as Elixir developers. So a quick timeline. I want to run through some points to maybe kind of paint the picture of how things were developing and how quickly things were developing, right? So the first language we're going to talk about is Algol, right? 1958, Algol. And why are we talking about Algol? I thought this was to talk about Lisp. Well, it's because two very important ideas appeared in Algol, and that was recursion and conditionals. The if statement first appeared. And the person who put those two things into Algol was Mr. John McCarthy. The second thing we're going to talk about is Lisp, obviously. This is the next thing. So very soon after his work with Algol, he improved on those ideas, made his own language called Lisp. At the time, it was really only intended to be a notation language. It was never intended to be written, but they went ahead and did it anyway. And now here we are writing with parentheses. Very soon, Lisp began to spread, and we see the emergence of things like MacLisp, right? You might think that this stands for Macintosh. No, it doesn't. It stands for Mathematics and Computing Lisp, right? So Mathematics and Computing was a department at MIT that later split into the AI lab, which we'll hear more about later, right? So the next big year, a lot of stuff happens in 1972. In 1972, the first thing that we're going to talk about is Smalltalk, right? Smalltalk was first published in a little bit earlier, but again, we're stretching the truth here, right? So this was at Xerox PARC. It was created by someone named Alan Kay. Also in 1972, Alan Kay visited MIT, where he talked with someone called Carl Hewitt about the actor model, right? And that led to Carl Hewitt. They talked about message passing, which led to Carl Hewitt developing the theory of the actor model, right? They developed the actor model because they were working on AI problems, right? So a lot of this ties back into AI, right? They also, in 1972, developed a project in France called Prolog. Prolog was also an AI program, right? They were interested in coming up with deductions based on a text. Nowadays, we call this natural language processing, right? This is another kind of foundational thing. We've gotten much better at it since 1972. It's come a long way, but this is, again, the origins. Also in 1972, we see C, right? So all of this stuff is pre-C. This was in Bell Labs. Coincidentally, they're also a telecom company. Again, if you know your history, you'll know that telecoms is going to come up very soon. So what's next? We keep developing, our time is moving on, and we get to Scheme, 1975. This is a project out of MIT, again, with two people, Guy Steele and Gerald Sussman. Another thing that comes up in this time, something called editor macros, also a program out of the AI lab. Nowadays, we call that Emacs, but this is the very, very origin of it is back in this day. Guy Steele of Scheme fame also was one of the very first contributors to Emacs back in the day. We also see Lisp machines first appearing in this time, right? So these are machines that are specifically designed to run Lisp on the bare metal hardware. So things have come fast enough. We've developed enough time in the last 10, 15 years that now we need machines that can do this stuff at a very, very fast pace, because otherwise our AI programs are not progressing fast enough. We're not making enough progress. 1984 is the emergence of GNU Emacs. So again, pretty big in the Lisp space. We see Mr. Stallman coming up with that also in 1984, Common Lisp the Language. This was a book originally written again by Guy Steele, who was from the Scheme fame. So he's also involved in the other big branch of Lisp. Yeah, you see Mr. Steele there. 1985, we've got another important book, very shortly after. Who is that? It's the same people. Again, the same people who are involved in Scheme. And 1986, Erlang. So now we finally get to Erlang, right? This is, if you don't know, a program that came out of the Ericsson CS lab. So what they were doing at this time in 1986 in the Ericsson CS lab was they were researching how to build new telecom switches, right? Some of the things they were researching include some of the things we've just previously talked about. New languages at the time, Smalltalk, Prolog, Lisp, all of these things that they were researching. Can we use these languages to build new telecom systems? Ultimately, they found, no, we can't. The furthest they got was with Prolog. So the original thing, if you read Joe's paper, Joe Armstrong's paper, was they originally wrote a system in Smalltalk, and then someone came along and said, hey, that looks like a Prolog program. And then they rewrote it in Prolog, and turns out Prolog was a much better fit. But Prolog also wasn't fast enough, and it also couldn't do everything that they needed it to do. So they came up with a new language, and we get stuck with the syntax of Prolog. 1998, Erlang goes open source. So this is sort of the beginning of the spread. And then in 2008, Lisp flavored Erlang comes along. So this is the kind of core of the talk here, right? This is bringing Lisp to the Erlang virtual machine. And not that long after, in 2012, Elixir first appears. So that brings us up to where we are now. We're all kind of caught up with the timeline. So as you can see, like a lot of stuff happening in a very sort of quick succession, and it all feeds off of each other, right? Like Erlang would not exist if Lisp didn't exist, and so on and so forth. Just goes back. So let's return to Lisp, and let's talk about one of the really cool things about Lisp and why maybe we can draw some connections between Lisp and Elixir. Macros, quote and unquote, are the key that unlocks the box that is labeled macros, right? So this is what we mean when we say code and data are the same, right? So quoting a symbol returns that symbol. Quoting a list returns a list. Unquoted symbols are treated as variables or function calls or function names. And unquoted lists are treated as function calls, right? So this is, if you've written Lisp, this is pretty standard stuff, right? The first element in the list is the function name. Everything after is the arguments. Pretty simple. So let's see some examples. This is all in LFE. So again, we quote a symbol, we get back that symbol. We quote a list, we get back that list. And if we don't quote a list, then it is treated as a program, and we call that program and we see some output, right? This is, if you've written Erlang, then this is just a call to the Erlang standard library. Okay, get to the good stuff already. Well, this is the good stuff. So back quote, this is the good stuff, right? What if we want to use a variable? So we said we can quote stuff. What if we want to use a variable inside of a quoted list? That's what backquote is for, right? So we can set some stuff. This is just setting values, and we can use backquote, and we can use unquote to extract sort of the values that are assigned to those symbol names instead of using the symbol names in that list, like we did back here. If I go back, right, we have a list. That list has symbols, but I want to get the values instead. So we have to use backquote. This is the key to macros, right? And we'll talk about that. So macros, we backquote, and we return a list. And we use unquote to put values inside of that list. And then when we call our macro, that list that we've written here is treated as code. This is expanded, and then it's treated as code. And we call this function, and we get our output, which is hello world, which is the same thing that we saw previously, right? Like this is nothing new, hopefully. So how do we do this in Elixir? What's the connection here, right? Like why are we talking about this? We can, of course, do quote and unquote in Elixir. We can write macros. You can't write a macro in the IEX shell, so we have to put it in a module. So we put it in a module and we get this back. And then we go to call our macro, and we would see an error. So we require it, and then we call it again, and now we get the output, right? So a couple more steps than the Lisp example, but really not that much. We're unquoting, we're quoting, and we're defining a macro. It's really kind of very similar. So if we were to, let's say, just put that quote block into IEX and look at what it gives us this whole huge data structure, right? And this is kind of complicated. So maybe let's zoom in a little bit, right? Let's look at just this one part of the data structure, right? This is the Elixir AST. This is the Elixir abstract syntax tree, right? We saw before the Lisp AST is just lists, but this is a little bit more complicated. We see two different types of data in here. But let's simplify it a little bit. Let's the middle thing is metadata, so we can get rid of the metadata. And now we see, you know, we've got a tuple and we've got a list. And again, like why are we doing this? It just kind of doesn't really make sense. So we put it into a list and simplify it even further. And now we've got ourselves Lisp. So you can see, like, we're really not that far off in Elixir from what Lisp is giving us. This is exactly the same thing. The AST of a Lisp call looks pretty much the same as the AST of an Elixir call. And that's for good reason, because they are, in fact, pretty much the same. So let's do a quick tour of LFE. So some practical examples. So if you look at this code and you think, I want to write that code in LFE, you're going to type in something that looks kind of like this. So it's just a simple form. And unlike Elixir, there's no do and end around it. You just write your module at the beginning and you write everything that comes in that module as the rest of the file. So if you want to have a private function, then you are going to write a defun, right? And a defun, we can also see examples in there of module documentation, which in Elixir looks like this, and in LFE looks like this, and function documentation, which I forgot to include in my Elixir example, but in LFE would look like that. And if you know what that character is in ASCII, you know what we're going to rename our failing company to. What's the greatest name for a failing company? So we will finally become an everything app now that we've named our company X, and we can export public functions. In Elixir, we export public functions by calling def. In LFE, we have to call export. This is just, you know, we can say the things that we want to export at the beginning of the module. This is much closer to what Erlang does, right? You'll see if you look at more LFE examples that LFE tends to stay very close to Erlang. It really is just a syntax on top of Erlang, where Elixir really kind of deviates in a lot of ways. Elixir has its own standard library. It has its own way of naming atoms, like to have the module names and stuff, right? So Elixir is a lot more different than LFE is. So we can do some pretty basic interop. Again, because it's all Beam languages, it all compiles down to the same thing underneath. So this is how you would call an LFE function. So it's not too really dissimilar from how you would call an Erlang function, except for the dashes would be considered minus signs in Elixir. So you have to put quotes around it. And it is a little ugly, to be honest, it is. In LFE, we have a convenient reader macro that means that we don't have to type the Elixir every time. We do still have to put an E in front of it, but we can have our module names be capital, no problem. And we can have our functions have underscores, no problem. Works just fine. We can also do structs from LFE. I don't have an example of that here, but it all works. There's some special forms around structs, but you can define a struct, you can call a struct, you can define it in LFE, use it in Elixir, so on and so forth. It's all the same thing. And that's because if you know Elixir and you know Erlang, you know that there's only a limited set of core types, right? So every language has the same core types. So let's look at a real example, right? So that was some kind of basic stuff. So let's implement a plug, right? What is a plug? If you've written Phoenix, then you've probably seen these before. A plug looks like this in the most basic case. It's a module that has two functions, and it has a behavior that it implements, right? But again, we saw previously that we can define modules in any language on the Beam, and the function calls can be called exactly the same. So why don't we define this with a different syntax? And in fact, we can. And this works just fine. This is no problem, right? So all we're doing here is we're defining a module. That module has two functions. That function gets called with some data. That data is the same. We can call it in any language. I'm not doing anything with the con here, but I could. Again, we have struct functions that can work on structs. So that's it, right? Now, if we want to use that, we don't have macro support. This is the big sort of problem with Elixir and LFE interop, is that anything that uses a macro in Elixir is pretty much off limits from LFE and also from Erlang and also from any other language, right? Maybe since both languages have macros, maybe there's something that could happen with rewriting the AST. Again, I showed some examples. The Elixir AST and the Lisp AST is really not that dissimilar. So theoretically, it's possible. But for right now, we're kind of limited. But yeah, you can call the Elixir plug and you can call the LFE plug and you can have them side by side, and that's really no problem. So thanks, everybody. That was a quick introduction to LFE. And if you want to get involved more, if you want to learn more, you can check out, I have a mix plugin. So you can use LFE and Elixir in the same project. And you can join the LFE community. There's a Discord server where people are hanging out, and there's plenty of repos where you can contribute to. So thanks, and hopefully you learned something.
Awesome. Thanks, John. Let me see what we have. Well, first of all, any questions from the in-person while I pull up the chat? Okay, no questions over here. Any questions? Okay.
Sure.
Here.
Why did we pick?
And it's on. You just have to yeah.
Why did we pick tuples for the Elixir AST? If it's easier to think of it with less.
Yeah. I don't know why. I can maybe guess. I would guess it's because of the third argument in the tuple, which is the thing that we threw away at first, which is the metadata. And I didn't show it in that one small snippet that I showed, but yeah, the Lisp AST doesn't have metadata in it natively. You can put it in there, but it's another thing. And then you have to just like have differentiated sections, which you might as well use a tuple for because we have them. I think that's what I would say. Yeah. Right. Well, but the arguments are still in a list, right? So the constant time is only saying the first, the metadata and the arguments, right? Yeah. Well, yeah. Yeah. I mean, it might have something to do with speed. You would have to probably benchmark it to see if it really makes a difference, but.
I have a question.
Sure.
I'm curious. I remember when LFE first came out in a pre-Elixir world, it was like, oh man, you know, the Erlang syntax is so terrible. It would be so nice to be able to have all this power without dealing with syntax.
Yeah.
But I mean, I think we all love the Elixir syntax a fair amount more. I'm curious, like in the modern era, presented with those two options, like why would, I'd love to just like, why would I pick LFE today in 2012 though, 100%.
No, sure, absolutely. Yeah. And I would say a couple things. Number one, the reason I got into it, it's fun. Why not? It's fun. Number two, I think that the reason that I wanted to talk about it here is because I think that it can teach you a lot about macros in Elixir, and Elixir macros are kind of maybe we don't talk about this sort of thing. Like it's a bit of a black box maybe to some people. I know me personally, when I first saw the quote and unquote thing, it took me forever to get my head around it. And then I wrote a little bit of Lisp, and now I understood quote and unquote, right? And now I understood how to write macros. So that's maybe one thing is to start to get your head around that. Another reason tooling might be, well, now that's not really a problem, but you might have seen, I didn't include this in my talk, but one of the things that makes Lisp really cool and interesting is because the syntax is so regular, you can write tools to work on Lisp generally, editor tools specifically. And that Lisp tool can work on any Lisp language. So we have this weird obscure Lisp language, LFE, but we can use all the tools that were built for Common Lisp and for Scheme and for all of these other more popular Lisps because the syntax is the same, right? Another thing, I didn't include it but in here, but I can't share it on up here, but I have a screenshot of, you've heard of Tree Sitter maybe? So Tree Sitter is a project to bring better editor tooling to different languages. How did they do that? they turned every language into a Lisp. You know, if you have tree sitter in your editor, I have Emacs, for example, you can type in tree sitter visualize, and it shows you your program as Lisp, right?
Very cool. Thank you. Thanks, John.
Sure.
Oh, more.
Yeah.
I'm gonna give you the mic.
First of all, not to talk, this might not be related to this. I really want to know how you did the presentation.
Oh, yeah. Yeah, it's this tool I found. What was it called? SliDev, SLI.dev. I just Googled Markdown slideshows, and it came up. So thanks.
Mattia has a question.
Yeah.
From remote.
I was actually the same as what you asked, Luke, was like, what are the use cases like right now? Like for me, like I just love writing Lisp, so that would be the reason. But
yeah,
I was thinking of practical applications.
Right. Yeah. I mean, that's probably one of the main points is that you enjoy Lisp, right? Like I said, to have fun. It is a more standard thing, but the other thing that is really cool is that it is interoperable with Elixir. So you don't have to choose, right? If you like to write Elixir, you like to write Lisp, you can write both. They can talk to each other. With the mix tool that we have, you can use it in the same project, and it all just totally works together.
We actually have another related question to that, which is, have you tried loading LFE modules in an Elixir project?
Oh yeah, works just fine.
Sweet.
I have with this mix tool that's here, LFE/mix. There's a mix LFE. It loads up an LFE REPL. You can call Elixir functions from there. You can also do IEX-mix, and you can call LFE functions from your Elixir REPL. So they're both totally cross-compatible.
Very cool. Very cool. Any other questions? Oh, awesome. Well, thanks, John.
Thanks, everybody.
Cool. Thank you.
Awesome. Yeah, thanks for coming, everyone. Again, I'm not prepared to say anything. So, Mattia, what do you want to say?
Yeah, sure. Well, again, thanks for John and Andrew for the talks, and thank you everybody, both online and in person, for coming. Thank you, Luke, for hosting and 7 shifts. It's that's super cool. We had people from all over the world tonight, and we had people in Toronto, which is